Lesson 6-8, Day 2, Systems of Inequalities. You will solve systems of inequalities. This time, the inequalities will have to first be put into slope-intercept form before you can graph them. So let's go ahead and start with the first inequality. X plus y is greater than 2. We want to move the x to the other side by subtracting x from both sides, or if you cross the line, you change the sign. So y is greater than negative x plus 2. So now let's go ahead and graph that inequality. The y-intercept is positive 2, so we're going to go to positive 2 on the y-axis and put a point. And then the slope is negative 1, so we're going to fall 1 and run 1. And we want to have a dashed line Now to figure out the shading, let's test 0, 0. If I plugged in 0, 0, either into this inequality here or this one here, let's just plug it in up here. 0 plus 0 is 0, and 0 is not greater than 2. Therefore, 0, 0 is not part of the solution. So I'm going to shade the half of the graph that does not have 0, 0. All right, let's move on to the second inequality. Negative 4x plus 2y is less than 8. We want to put this in slope-intercept form. We want to move this x to the other side. If you cross the line, you change the sign. So it's going to be 2y is less than positive 4x plus 8. Divide both sides by 2. Y is less than 2x plus 4. So the y-intercept is 4. And the slope is 2, so you're going to rise 2 and run 1. We're going to have a dashed line again. Now let's go ahead and test 0, 0. I could plug it in here or go back to my original. We end up with 0 is less than 8, and 0 is less than 8, so we do want to shade the half that has 0, 0. So here's my boundary line, and I do want to include 0, 0. So the solution to this system of inequalities are the points that fall in this dark blue section where the two shadings overlap. You may want to pause the video and try the next one on your own. The first inequality, y is less than or equal to 3. Remember, when you only have one variable, just an x or just a y, it's either going to be a horizontal or vertical line. And in this case, we're talking about all the places on the graph where y is less than or equal to 3. So we are going to go onto the y-axis and put a point at 3. And we're going to make a horizontal line that's going to cut through the y-axis at 3. It's going to be solid because of the symbol that's used. because it includes the points on that line. And we want all the points that have y less than or equal to 3. Well, all of these points below the line are where y is less than or equal to 3. Now let's go ahead and graph the second inequality. X plus y is greater than or equal to 1. Put it in slope-intercept form by moving the x to the other side. Y is greater than or equal to negative x plus 1. So our y-intercept is 1. And the slope is negative 1. So we're going to go down 1 and to the right 1. This time it's going to be a solid line as well, because it can equal the points on the boundary line. Now we're going to test out 0, 0. If I plug in 0, 0, 0 plus 0 is 0, and 0 is not greater than or equal to 1. So 0, 0 is not part of the solution, so I want to shade the part that does not have 0, 0. So the solution to this system of inequalities is the green part where the shading is overlapping. All the points in that section are solutions to the system. Now, one thing that I didn't have an example of here is if for some reason at any point when putting it in slope-intercept form, if you have to divide by a negative, like if this would have been a negative 2y and you divide by a negative, remember when solving inequalities, if you have to multiply or divide by a negative, you have to flip the symbol around. So keep that in mind.